Hey everyone, how you all are doing? Hope you all are doing great. My name is Parth Varu, Event Program Manager for Microsoft Reactor India. Good morning, good afternoon, and good evening to you all who all are joining us globally. And welcome to our MVP Connect. Before I bring in Sonia, who is our guest speaker for today's session, let us go through our code of conduct. We are all here to learn together. So please be respectful of other people's views, understanding of differences, being kind and considerate in the way we engage. Yes, obviously, we do encourage you all to participate. Please drop all your questions in the chat section and then we take questions from there. Yes, I'd now like to bring in Sonia for today's session. Hey, hi, Sonia.
Hey, hi Parth. Hi, hello everybody.
Hey, folks, Sonia is in a ghost mode today.
My network is a dodgy, so I won't be sharing my screen. Sorry, I mean sharing video. But I hope you're able to hear me properly.
Yep, we can hear you and we are live.
Yeah.
Yeah. So, Sonia, what do we have for today's connect?
So as you can see on the slide, we are going to discuss. We're going to have some architectural discussion around how to build CI/CD pipelines for sample machine learning project with Azure pipelines, right? So, um, actually, those who've joined, I just want to set expectations so that you will figure out if the session is for you or not. What can you expect from the session? Are these 3 points, right? So first, we'll be discussing some architectural nuances of build and release design for machine learning projects, and then we'll do a end-to-end demo on the same thing. And then I'll lastly walk you through um, uh, the demo generator. So basically, using that, you'd be able to demo the entire thing by yourself. Right. So I'll share some of my learnings and discoveries that I made while doing this project. So this is what you'll be getting from the session today. But at the same time, these are some things that you should not be expecting because we just have very limited time. So I won't be able to cover the basics of Azure DevOps or Azure ML, and we are not going to do any deep dive of the code. Right, so there is a code base. We have scripts, but I would leave that for you to go in depth after the session. I think that would make a lot more sense, and it will give you a lot of time to reflect as well. So yeah, that this is what we have. But I hope.
Yeah, please, please. The floor is all yours. You can go ahead and start the session. Viewers, pull back. We have a fantastic session coming in now. Over to you, Sonia.
Yeah, thank you, Parth. Thank you. Okay, so before I begin the session, just a short intro about myself. I am Sonia Mehta, and I am currently working with EXL Healthcare, and I'm helping them with ML Ops, and data engineering as well. So I worked on computer vision projects, NLP projects, building cloud native applications as well. And this is my LinkedIn and GitHub references here. So if you guys want to connect, please, I'll be happy to connect with all of you. So yeah, let's jump into the session, right? So just to give a brief like a warm up before the session itself. So we're going to talk, like, let's just like walk through the ML application life cycle. So from a bird's eye view, we all know that it has three steps, right? So first we prepare the data. Data is basically the entire thing driving the machine learning project. So there are a lot of steps involved in cleaning the data, ensuring we have selected the right features, we have fine tuned the features, and we have created a perfect data set. Okay. And once we prepare the data, we come to the experimentation stage. And this is where we try a plug and play of different models. Um, and usually we use a Jupyter notebook, or we use VS Code. We choose our favorite IDE, we build the model, and we tweak a lot of coefficients, parameters here and there, learning rate, and all of that. And then we figure out a best model. So experimentation is the only thing that drives ML. So once we figure out the best model, we test it with some new sample data, see if it's generalized well enough. And now it comes to the deployment stage, right? So this is where your ML application becomes useful to the end users. And one of the ways to deploy it is as a web service. Okay, it's one of the most common methods. So web services. Okay, before going there, um, um, what we generally do is in any uh, corporate setting, if you look at how we approach ML projects, is we take the model, and because it has certain environment dependencies, we bundle all of those environment dependencies into a Docker image, right? So Docker or any kind of image building tools that are available in the market. So you use that technology to basically bundle up your dependencies and create a container, right? Now this is basically the backbone of the model, so that this can be run anywhere on any kind of infrastructure. And once we have that set, um, then we can deploy it in any way we want it, right? It's a batch service or a web service. If you want to create an endpoint, so web service is basically and creating an API, basically an endpoint. So you hit the endpoint, which redirects it to a server, which is hosting a model, and we basically send a JSON input, that is our sample data, and the machine learning model that is deployed will take in that data, churn it, give us the result back. So endpoint helps us to coordinate all of that activity. So that is a web service, right? So a lot of tools available: Nginx, GUnicorn, Flask, Django. So these are some of the tools that we have in the market, which helps you put your web service together, right? So within this application framework, some of the common issues that architects face, right, or even the developers face, is firstly running experiments, right? So we all know that in the experiment phase, we would there'll be a lot of times when the infrastructure is not sufficient. We want to run a model on a better hardware. um, um, so we basically want to test it on different VMs with different CPUs and RAM configurations. And at the same time, we also wanted to we want to keep a track of all the models that we're running, right? So we need a mechanism in which we can basically log the model metrics and the version of the model, right, and the changes that we made to the model. So it's basically keeping a track of all the versions. So that lack of that creates a lot of issues, right? And then we have validating solution, which is basically becomes how good your solution is, and you come up with the discussion of which metrics should we be looking at to validate it. And thirdly, it is deploying solutions. A lot of times we face this issue of how do we make our deployment very seamless, right? So every time you train a new model, how do we create a Docker image and push it as a web service very seamlessly, right? Generally, if you look at the way the naive approach to this is, there'll be two teams, right? There'll be one team which will be developing and giving us the pickle file, and then there'll be an operations team which will sit and make the image and then put it it's a very manual approach involving a lot of teams and manual effort, right? So there is a lack of iterative deployments, and obviously, because we have two teams and all of that, there'll be a lot of long chain of approvals as well. And another issue is retraining model, right? So as and when we get some user feedback and we want to go ahead and change something in the model, there are lack of reusable scripts, correct? And we also have um, this inability to decide which thresholds should be used for triggering the training even, right? Like, let's say I make some changes, but the model which is already in production, if it's good enough, why do I have to retrain it, right? The train, okay, even if I train it, I don't have to deploy it, right? So we need some thresholds to make that kind of judgment, that evaluation, right? And then we have monitoring solutions. So even that's a big challenge. Common issues are not a lot of teams are able to track the data that's coming into the model. They're not able to capture the data trends. They're not able to capture the performance of the model. So these are the common issues that are faced, right? So today, what we're going to see is basically these two services, right? And how they both combine to solve these multiple issues that we discussed in the previous slide. So Azure ML is a service which provides a cloud-based environment, okay, where you can do plethora of activities. You can develop, you can train, you can test, deploy, manage different experiments, version them, and track them as well, right? So basically, Azure ML has these several APIs or SDKs, right? So you just have to call that function, and you'll be able to register it, track the model, and it has all these inbuilt functionalities. You don't have to sit and install the third-party tools to do it yourself, right? And we have Azure Devops. So Azure Devops is again the service, as I've provided the definition. It is basically a service which provides version control, project management, automated builds, testing, and release management capabilities. So it covers the entire application lifecycle and enables DevOps capabilities, right? So what we're going to see today is the amalgamation of both these services. So from Azure DevOps, we're going to have a code base, right? We've written a code base. In that code base, we are using Azure ML SDK, and that SDK is going to basically develop the model. Sorry, it's going to create the workspace. We're going to train the model. We're going to create a Docker image. We're going to deploy it, and everything will be done using Azure ML SDK. Okay, so um, so this is what we're going to see. So yeah, let's do a deep dive right into the first part, which is the build pipeline. So when it comes to normal applications like .NET or something, the build is a little bit different from how machine learning works. So in machine learning, build, you have to see it from the perspective of training and building the Docker image. Okay, building the scoring image. So let's see how to automate training and building scoring image on ADO. So I've just put up like an architecture diagram. Okay, now this is going to make it easier for me to explain when we come to the demo. So okay, so let's look at this image. So what do we see here? We have a Linux VM agent. Okay, so let's imagine you're giving a you've been given a VM. Okay, it has Linux Ubuntu installed on it, right? And now what you have to do is, your task is, you will have to create you have to automate the training of the model and creating the scoring image, right? So um, so one of these designs I have captured in this diagram is, you ask Azure DevOps to give you provision a VM for you, okay, and you ask an Ubuntu version VM, and on top of that VM, we are going to install some dependencies, right? So obviously we need Python. So you define which version of Python you need, right? So Azure DevOps internally has certain tasks, okay, where it can install Python for you. You don't have to do anything, right? You don't have to write a script, pip install anything. It has a inbuilt module. You just have to call that, right? So first, you set your environment on the Ubuntu layer, on the host machine. So you put the Python layer, and on top of that, you install Azure CLI for authentication purposes and for other purposes, right? So Azure CLI. Then you put your Azure ML SDK. Then you put other libraries that your model would need, right, for training, like scikit-learn, NumPy, Pandas, whatever. So you put all of them, right? So once the layer is ready and all the environment is completely set, okay, now you go on to the next step, which is, as you can see, the first step is create get or create workspace. Okay, So basically, what this script is going to do is it's just going to call an API, right, through the SDK layer. It's going to call an API which will, um, um, okay. Before we even go to 1, 2, 3, 4, 5, I want to cover this part, right? So what you see here is basically the volume which is mounted on the VM, right? So this volume will have your source code, okay, will have your configuration files. Basically, that configuration file can have your subscription ID, whatever resource group name that you want to give, and the workspace ML workspace name that you want to give. So you can establish those configurations here, and each of these steps can generate some intermediate output file, right? So it can write into some file, and that file will also get stored in the volume. Now, this volume is a source of truth, because once the build is completed, this is the volume which will become an artifact. Okay, so artifact, think of it um, as a as a package, like that you want to share between teams, that you want to share between projects. Okay, so after this entire build is completed, it's going to have, along with the source code, it's going to have several intermediary files, which is then going to be used for our continuous delivery pipeline. Okay, so this pipeline, look at it from the continuous integration perspective, right? Okay, so let's go back. So we have the VM, we have installed all the dependencies on top of it. Now, what we're going to do is we're just going to create a workspace first. Now, why have I put the Azure ML thing logo here? Is because this is basically going to create an Azure ML workspace for us, right? Now, when we do a creation, now creation activity will happen when this script internally will check if on Azure, for my subscription, do I already have a workspace created with this particular name present in my configuration file? If not, let's create a new one. So it's either get or create, reuse the same one or create a new one. So let's say it doesn't find something, so it'll create a workspace, and internally Azure ML will take care of deploying all the services, right? So internally, it will deploy a key vault storage. It will deploy. So key vault is for basically all the access permissions that are needed. Then it will have its own studio, ML studio, that's going to create. It's going to create a storage container as well for you, right? So it will take care of all the things, right? So once we have that set up and a resource group is created, now it's going to go to the next step. Okay, now in this step, the way I've designed it is it's going to train the model now. Okay, so once we have the workspace ready, we have a script in the code base. Okay, and we're going to instruct Azure DevOps to run that script on the Linux VM itself. Now, this Linux VM is basically the host agent. Okay, so we are not provisioning any other machine, because I'm running uh, a very simple model which doesn't need a lot of RAM capacity or CPUs. So I'm going to run it on Linux VM directly. So it will call a training script, okay, and it's going to run it. Now, this training script, again, it's going to because it's running on the local environment, it needs some way to register it within the Azure ML workspace, right? So we are again going to call an API, say Azure, indicate to Azure ML that, hey, we have started an experiment on a local machine. And once the experiment is over, we're going to say, yes, the experiment is over, right? So we're just going to register an experiment in Azure ML workspace with certain parameters, right? So once the training is complete, it's going to say experiment completed. Nothing is happening on your Azure ML studio. No VMs are created here. It's all running in your host agent. Okay, so once the training is completed, okay, so we have the pickle file now. Okay, now what we're going to do, this intermediary step, the second step is going to write some output, okay, to our volume. Okay, so the way I've designed it is this step is going to write the details of the experiment name, and the model name, the model pickle file name, and everything is going to be stored here, and output pickle file also is going to be stored in some output directory here. Okay, now we come to the third step. Now this third step is basically going to check, it's basically an intelligent check, okay, of whether you should deploy this model or not, whether you should even continue with step number 4 or 5. Now, how do we take that decision? So basically, before so once you have trained the model, we know certain metrics of the model, right? So it might give us, so if it's linear regression, we might have MSE, okay, least we will get some errors and metrics of the models. So once we have those RMSE or these metrics, right, we can use those metrics and compare it with the model that we have in production currently. Okay, so imagine that I ran this build pipeline before and it worked and it has registered a model already in my workspace. So that will is basically the model that is gone into production. So I'm going to take the latest model that is running in production. I'm going to compare the metrics of the latest model, the model that I've trained, and the model deployed, and upgrade this model, the latest trained model, if the metrics are better. Okay, and I'll upgrade it. Okay, so this is basically an evaluation checkpoint. And once this is cleared and we know that yes, we want to upgrade it, it's going to move to step 4. If the metrics are not any better, it's going to skip 4, 5, and that's it, right? The build process is going to be completed. It's not going to generate any intermediary flights later on, right? So let's say we have a good model with us. So we go to step number 4. Now, this is again going to call an Azure ML API, and it's going to register the train model in Azure. Now, why do we do this step? Why do we need this step? Now, this is so that we have a model versioning in place, right? We know that this is the model which was deployed on this particular date. It was registered on this date, and these are the scores, these are the tags, and we are letting you know that okay, this has been this has been registered on Azure ML now, right? And the pickle file has also been uploaded there. So that's why I put the Azure ML symbol here, because we are calling an Azure ML API. Now, once we have registered it, now we come to the final and the most important step, which is creating the scoring image. Now, why have I put a Docker symbol here and why have I put a Azure ML thing? Now, generally, when you want to create a image, we all manually install Docker. Then we do a Docker, we create Docker file. Then we do a Docker build and all of that, right? Um, if we use Azure ML, that entire process can be outsourced. You don't have to bother about anything. Azure ML will just need certain parameters from you. So you'll have to point it to the, you'll have to give it a couple of things, right? First, you'll have to give a scoring script to Azure ML. So you have to say that this is my execution script, which needs to be the one deployed as a web service. Okay, and later on, I'm going to show you in the demo how the scoring script is written, right? And so once you have the scoring script ready, so you just call an API to say Azure ML that create an image for me with this execution script, with this particular image name, and these dependencies, right? So we can create a text file with all the dependencies, like similarly, like all these dependencies that I have shown in for the on the host machine, right? So we can create a similar conda dependencies.yaml file, and we can have that along with the scoring execution script and everything. We can send it to Azure ML, and it will internally take care of deploying the image for you. Okay, so once the image is deployed, we are done, right? So now this will also write some intermediary output. This will also write some intermediary output. This will say where is the image located, which container registry it has gone to, and all of those things, right? So it's going to communicate and it will write everything into the volume. Now this volume has become our artifact. Now this is an end-to-end build process. Okay. um any questions here, like anything that obviously I'm going to show you the code scripts later. I'm going to show you the end-to-end demo, but this is just a rough architecture of how things are going to be moving, right? um so yeah, just like to take a pause. Yeah, even I'll have a sip of water. Yeah. Okay. um so this is the build pipeline, right? So let's So the
Hey,
second,
Sonia, sorry to Ravinder. We have a question.
yeah,
Can we manage VM source image with external sources like Mask or CNN?
can you repeat the question? Can we?
Can we manage the VM source image with
Okay.
external sources like Mask or CNN?
Oh, you want to manage the VM source, VM image itself. So you're talking about this virtual machine, right? Which is provisioned by Azure DevOps. So there's a doubt here. Like, which VM are we talking about? This VM or the VM that we can potentially train the model on?
So, where are the security controls in Docker image creation? Can they be locked down so only the ML model updates into the Docker? Yeah, into the same VM, this thing. Yeah.
Okay, so I'm not sure what mask RCNN generally does for VMs. I'm not sure about the process, but what I believe is Azure DevOps will only give you set of images, right? You can either have Mac OS installed, Ubuntu installed, or CentOS, I think. So you have these three, four kind of images, but on top of that, you have all the flexibility to install uh, other things, right? Like so as I mentioned, you have flexibility to do anything on top of it. And once you have that ready, oh yeah, so you can have your mask RCNN installed if that's what you mean, and TensorFlow, whatever it is, installed on Azure DevOps. VM, yeah. And coming to the Docker scoring thing, see, the security, it works in this way, right? Azure ML internally, it will require certain parameters. So I'm going to show you that script and that exact call actually. So initially I didn't plan to do the code deep dive, but you can when you go to the code repository, you would see it to yourself, right? So in that one score, that scoring script alone, you will see that Azure ML, once it gets those parameters of where what is the script and what image needs to be created, it's only going to do that for that particular model, the model that has been registered, right? It's not yeah, so basically if you're saying that how do we restrict it to only certain machine learning model, yeah, there are parameters that you can change in that API call to restrict it. I'll show you that as we go deeper into the session, right? So we have 30 more minutes. Yeah. So, Pat, I'll move on and we'll take the questions, the few more questions later on. Okay.
Yep, yep,
So,
yep.
yeah. So what we saw was the build pipeline so far, right? Now, let's see how to release the model. So, once the scoring image is ready, um, we are going to we basically have to deploy it on some kind of an infrastructure, right? So that we can consume our model as a web service. And now, how I ideally want to do the release is in a staged way. I want to first push it into QA. Okay, I want to push it on a very small container, probably. With Okay, so once we push it into that container, we want to test if everything's working fine. And then after we do all the checks and approvals, then we want to push it to prod. So on prod, then we can go ahead with some other strategy, right? We can create a Kubernetes cluster and deploy our image in that fashion, right? So basically, this is a staged deployment design. So okay, so this is the diagram for that. So basically, if you look, there are two stages. The release has been planned, and both of these stages we are going to provision a new Linux VM from Azure DevOps, and as we did the build, we are going to install the same dependencies. Okay. Now, why are we doing that? Because we want to call two scripts, right? We want to first deploy our model on Azure Container Instance, and we want to also do some integration testing and functionality testing, right? So to run these two scripts, we need Python, we need CLI, CDK, other packages. So we install all of that. And once we do that, the first step is we call a script which will internally call Azure ML SDK. That SDK will deploy our image on a Azure container. Okay. Now Azure ML will internally take care of which container it should go to. It will create the container registry to save your image. It will create a container instance for you, and it will push your image there, and it will take care of all the things, right? All you need to mention in that API call is what is the CPU that you want to configure, CPU, RAM, and all those things, that how you want to design your container basically. And you give the image location, right? Now, how do you get the image details and all of those things which were defined in the previous build process? So that's where the artifact code base comes in. So I'll take you back to that diagram, right? So this is where our entire code repository was stored and created. So the build process created a repo, and this gets carried forward to the release, right? So the moment build is completed, Azure DevOps has this capability that it will publish that volume as an artifact, and that artifact, the moment it's put into a location, it's going to trigger a release pipeline. And when it triggers a release pipeline, my QA deployment will start and my production deployment will start later on, okay, after all the approvals. So we're going to see that in action, okay, some in few minutes. So the QA stage, as I told you, it will go install, so it will go and create an Azure container instance and get all the image details from the artifact code base, and let's say we have deployed it there. Now, second thing is to ensure that everything is working properly. We will have a functionality testing script. Now, this script is basically a simple Python script. It will fetch the web service from the Azure ML workspace. It's going to take that, it's going to pass some sample data and get some result back. If it gets the result in a satisfactory way, it's going to say testing successful and our QA deployment is over. Now, to move it to production, Azure DevOps has its own internal features, right? You can add in reviewers, approvals, pre-deployment checks, gateways. So there are multiple things you can do, and I would like you all to go and explore that yourself. And even in the demo later, you will be seeing how that happens. So let's say I am the approver of pushing this model to production. So I'm just going to approve this, and I'm going to comment that everything works fine. Let's push it to production. So once it goes into production, it's going to do the same thing. It's going to ask Azure DevOps, please provision a VM for me. It's going to install everything. And now we're going to deploy the same image on multiple containers, and we're going to have a Kubernetes layer sitting on top of it, right? Now, I don't have to manually do any of this. Azure ML will take care of it, right? So you just have to call an API, pass the image details, pass the Azure Kubernetes cluster configurations, that this is the kind of VM I'm looking for. These are the number of agents I need and all of that. And you give that to Azure ML, it will take care of the deployment. And once it's deployed and we get the endpoint successfully back, we are going to do another functionality testing on top of it, see if it works fine. And that's it. We are done with the deployment on production as well. Okay. So this is a simple staged release that we can design for our ML projects. So these are just simple design ideas, right? You can add so many more layers and functionalities to this. Like before number two, you can have many more scripts to test your model. How is it reacting if I give it a very weird kind of data, right? If I give let's say negative numbers as features, how is it reacting, is it rejecting it properly or not? So we can do a lot of other testing in an automated fashion, right? So I've just done a simple functionality testing, but there's a lot more that you can do here. Okay, so we're done with the release as well. um, okay, so now let's just see all of this in action, right? So we're going to open Azure DevOps now, and I'm going to run this end to end, and let's see. Okay. Are you all able to see my screen? Path, can you
Yep,
confirm if you're able to see my
yep,
Azure
yep,
DevOps?
yep. Yep, we can see the screen.
Okay, okay. Uh, okay. So, so this is Azure DevOps in from the UI perspective. We have a lot of things here, right? But the services that I have used is repos and pipelines. Inside pipelines, I've used build pipeline and release pipeline. These two things. So let's come to the repo. This is basically the entire repo that I have for my project, right? It has configurations, it has helper files. So basically, all of the code that we saw, training, evaluating the model, registering the model, deploying the model, everything is done. These are the codes inside this folder. So you can check this out later. I'll tell you how to access this code repository. Now let's see the end-to-end run for this. Okay, so I'm going to run the pipeline. So when you're running this, the Azure DevOps will ask you to select which VM do you want to run this on, right? Hosted by Azure Pipelines or default, something that you have provisioned. So I'm going to select Azure Pipelines and I'm going to give Ubuntu 20.4 as agent specification. And this is the master branch that I'm running it from, right? So I have all my code sitting in the Azure Git repo. And from the master branch, I'm going to create my pipeline build. Okay, so I'm going to start the run now. So basically, now it's going to wait for the VM to get provisioned, and it's going to do multiple tasks here, right? So you can see from from the list of tasks here, right? So you can see what are the different tasks that we saw in the architecture diagram. You'll be able to correlate it now. So first, we are checking out the repository. So we are basically copying the entire code onto the VM volume. Then we are installing Python. Okay. So we go and we install Python 3.6.15. This is the version that we're installing. Sorry. And so once the Python environment is installed, then we're going to go ahead and install all the other dependencies, right? So Azure CLI, and I've configured some requirements, and you'll be able to see that in the repo. So let me open this in a new tab. Okay, so it's gonna take some time here. So it's going to collect all the libraries, Azure ML SDK, and it's going to deploy all of that. Sorry, install all of it on my VM, right? And then we're gonna go step by step, right? It's gonna create the workspace and start the training. Let's wait for this. Right. So now we have finished installing all the requirements. this is just going to call an API and create the workspace. First, it's going to check if the workspace exists. So in my Azure environment, I have no resource groups created so far. So it's going to go and create a resource group for me. So as and when it does this, I think I can show you this as well. I can. So what I'll do is, instead of taking you through the UI route, I'm going to um, let me go here. Let me download the YAML file. Export to YAML. Okay, so I'm gonna just switch the tab, share this tab instead. Yeah. So let the build pipeline complete, right? But what we are seeing here is, so I've just created this new YAML file. Now this YAML file is basically whatever you see in the whatever you see here, right? How do you even define this entire build? There are two ways to do it. Either you do it from the UI route, right? So you configure all of these jobs, these tasks within the pipeline on the UI, or if you want to track the changes, you want to do version controlling and everything, you can just create a YAML. Okay. Now this YAML um, has basically a structure to it. So you're going to create a job. You're going to uh, define which Ubuntu pool that you're going to use, right? And after you define the VM image, these are the steps, right? So you define each of the task here, right? So using a Python version, you don't have to do anything by you don't have to write any code. Azure DevOps has its own internal module that you can use. To run a shell script, you just have to call the shell script too, and it will install all the requirements that you have. Now, um, this is the script that we're going to run, right? So this is available inside the root directory environment setup. If you open the install requirements.sh, this is what it's going to run here. Like that, Azure CLI, this task is going to basically run the Python workspace.py file. This is going to create the workspace for me. This is going to start the training for me. This is going to evaluate the production model with the newly trained model, right? This task is going to register the model. So every task is basically running a Python script, correct? And it's also, so once it finishes the scoring image, we're just going to copy all the files from the artifact directory to the build, sorry, from the source directory, which is our root directory, to the artifact staging directory. So these are basically logical bifurcations that we have, and this will be done on the VM level, right? So on the volume, we are going to transfer everything from source directory to artifact directory, and once it's all done, we are going to publish it. So let's go back to our job. Okay, so we've seen that, okay, it's finished creating the workspace, and we have our training has also been completed. So let's go and have a look at the training. So we are running the training script. This is basically the alpha value that I've decided. Then we create a pickle model. Sorry, we create a pickle of our model. Then what do? We register the experiment into Azure ML, right? We submit all the experiment details. Now Azure ML knows that, okay, training has been completed and we have the model ready with us, right? Then we evaluate the model. Once the evaluation is complete and it says that, oh, there's no model in production currently, so why not go and register the model? So it's going to go and register a new model now. And once it finishes registration, it's going to create the Docker scoring image. Let's wait for this to complete. So while this happens, I think it'll take another 3-4 minutes. Let's go to the code, right? So we saw, and the entire environment setup on the VM is taken care by this script, right? So we have all the requirements established here. Then let's go to the ML server. So all the zero scripts starting from till 30, right? These are all the scripts that we're using in the build pipeline. When we are training our model, sometimes we don't want to train it on an Azure VM, right? We want to train it on a separate VM that we want to configure. It can be a GPU, it can be anything. So if you want to create your own VM, okay, then you can attach, basically you can create provision a VM in Azure ML workspace, right? So there is an option in Azure ML. There's a module called remote compute. So you can go and create a remote compute. So you can define the VM name, VM IP, password, all of that, all the configurations here, and create a VM. And that VM then can be used to train your model. Okay, that's another way to train your model. So there are different ways to train it. I have just trained it on the Azure DevOps agent itself. So later on, after the session is over, you guys can check these three scripts. So these three scripts basically train the model on different environments. Okay. Um, and evaluation script basically looks like this. It's just going to so all these are all the intermediary files, right? So it's going to read from the run id JSON. It's going to read all the model experiment name, run id, and everything. It's going to create a new experiment, and it's going to check for the latest model that has been created. And from that latest model, let's get all the metrics, and we're going to compare the MSE, right? So we're going to compare the latest MSE with the production MSE, and we're going to see which one is better. Okay, and if it is better, we are going to create a new run id JSON file, right? And we're going to replace the old run id with a new run id. And once we do that, it's going to trigger the next script. So like that, there are several code scripts here that you can go and check it out after the session. We won't be deep diving into it. Similarly, I there are scripts to deploy the model on ACI as well. So Azure Container Instance. So as I told you, all of these scripts are basically calling an Azure ML API internally, right? So it's using for creating, accessing the model. We have the model module. We have the to create Docker image. We have the image module. To create a web service, we have the web service module, right? So you can just use these and go ahead, um, outsource all of your work to Azure ML, right? So this is how you create your web service. All you need is tell it these are the configurations and create my web service from these configurations. So I know I'm jumping in on the code, but yeah, I'll because once the pipeline is finished, so as you can see, our pipeline is done, right? Our entire build pipeline is complete now. So we have created an image and everything. Now, after it's finished, the way I've configured it is, if you go to release now, it has automatically started a release, because the last step of the pipeline is basically pushing the entire code repo into an artifact directory, right? So the moment something gets added there, it's going to trigger a release pipeline. Now let's look at the release pipeline. It looks something like this, right? This is the artifact Devops for AICI. This is my code repo, 32nd um, uh, release, sorry, 32nd artifact that we have. And this is starting the first stage, which is deploying on the QA. Okay. Now, within this, there are several steps, right? Work items. So we have multiple steps here. We have initialize job. So you'll get your entire I'm not going to go into the logs, but let me show you this, right? Let me go on. tasks. Yeah, basically it looks something like this. So this is how you configure it. So release pipeline, the first thing, we're going to generate a new VM. Okay, on that Ubuntu VM, we are going to use a Python 3.6 version. We're going to install that. We're going to install all the requirements, CLI, SDK, everything. Then we're going to call the web service ACI script. That web service will generate an endpoint for us. That endpoint is going to be consumed, and we're going to test it using our Python script, our local Python script, right? So this is how it looks like. Similarly, the production one will be the same. Just these two scripts will differ. This it will call the Kubernetes API. Okay, let's go back to the release, and you can see it has been successfully deployed. Okay, so that means the testing has also been completed. Correct. Um, and now you can see it is not pushed to the production yet, because it's waiting for an approval, right? So I've configured it to have an approval. So let's go and approve this, right? So I can approve this, and I can also defer the deployment for later, saying that let's schedule it to a later time because I want to continue my testing further. So okay, I'm just going to approve this, right? And it's going to queue my production deployment, and it's going to start this AKS deployment as well. Now let's go into our Azure um, portal and see the resources that have been created. Oh, just to give you a heads up, the AKS deployment will fail because the subscription that I have, my quota is only it only allows me to deploy four cores on a particular region, and AKS has a minimum requirement of having 6 cores. So it will hit a quota issue and something it will fail, right? But this should ideally work for um, um, the subscriptions that are paid, right? I have a so this so let's go to the Azure ML portal. So I hope you're able to see it, right? um, let's go to Azure machine learning. So you can see we have Azure ML workspace that has been created. Okay, and let's launch the studio. Okay, it's opening in a different page. Share this tab instead. Okay, so as you can see we have okay, so an experiment got registered with Devops AI demo name. It got completed. If you look at the models, our model was also registered here, right? Version 1. And if you click on this, it's going to tell you that this is the version, and the other details of the model, right? So let's go to endpoints. Let's see what has been deployed. We have an ACI web service deployed. Okay, so you can see it's a container instance, and our container instance is healthy. If you go to consume, this is the REST endpoint, right? So if you look at the Python script here, it also gives you, so basically, um, if I hit this particular endpoint and give it sample data, it's going to run the model and give me the results back. Okay, so this brings me back to this. So if my Azure Kubernetes also had worked, it would have created another instance, Kubernetes instance, and deployed it over there. Okay, so um, so this is, I was just showing you the Azure machine learning studio, right? If you let me just open my resource group and share this tab instead. Okay, so this is basically These are all the resources that have been created in my resource group, right? So we have a container registry. This is where the image is stored. This is the container instance. Internally, Azure ML takes care of creating all of this for you. This is the Workspace Studio. This is application insights for web service to track all the API calls and everything. This is the key vault. It has all the access permissions stored. And this is the storage account, right? This has all the logs, intermediary logs, everything that has been stored in the storage account. So when we create the workspace, all of this is Azure ML takes care of creating all of this for us. Okay. So quickly, let me just share the last part of the slide. Um, so we saw all of this into action, right? We saw the build pipeline, we saw the release pipeline, and now what I want you to do next is I want you to log in into these two links. I'll have Path share this with the team. Basically, when you get into those links, you will be able to generate a demo, the same whatever pipeline that I just showed you, right? If you follow the steps written in this blog, you will be able to have the same thing in your Azure DevOps organization as a project. You'll be able to create it there, and you'll be able to run it all by yourself, right? You don't have to just follow these two links, and you should be good to go. And once you do that, then you'll be able to deep dive into the code, see the nuances there, how the APIs were called, what parameters were passed, and then a lot of it would make sense. And before I end the session, these are some of my key learnings, actually, some things that I want you, few things that I think will save a lot of time for you guys when you sit and run this project. So, first is if you have a free subscription and you are planning to run any pipeline on Azure DevOps, you won't be able to do it without getting approval from the ADO team, right? So, basically, there have been a lot of cases before where people were misusing the VMs that were available on Azure DevOps. They were running very heavy tasks on that. So Azure DevOps came up with a restriction. Now, if you want to run any project on it, first you have to go tell them that this is the project that I want to run. Then they will approve some time. So basically, you get some minutes, free minutes to run your jobs. So you'll need to get that approval, and only then you'll be able to run this pipeline on your Azure DevOps account. Second thing is the pip version, right? So in the code repository, if you look at the scoring image, right, the Docker image that we're creating, the Docker image needs some dependencies that needs to be bundled up, right? So in that dependency file, there is a little change that you have to make there. Because this project is built on Python 3.6, you have to downgrade the pip version to 20.1.1 as well. So in that particular file, if you change the pip version this way, it's going to save you a lot of troubleshooting and debugging. So it took me a lot of effort to figure that this was the missing link. So once you downgrade it, you will be successfully you'll be able to create the Docker image successfully. And third one is, I saw this problem that if you have, let's say, you have your resource group name, you have decided it to be ABC. Okay. Now you deploy it once using Azure DevOps pipeline. You see that something is wrong. You delete the Azure resource group and you try to repeat the process again. Now, if you do this repeatedly, like on the same day, if you do the deletion of the resource group and repeating the creation again and again, like more than 10 times, then what happens is the Azure ML, right, somewhere in the back end, it's going to act very erratically. It's going to create some permission issues for you. So because of that, your training and all of those might fail, right? So this also took me some time to figure out. So please be aware of that. Don't delete your resource groups again and again. What you can do instead is, if you want to go for a new deployment, change the resource group name altogether, or you can go to the key vault, copy paste all the permissions that have been created in the first time and ensure that the same key vault permissions are passed on to the repeated I mean the future deployments as well, right? So these were some of my learnings after the project. Yeah, so once you figure out how to I mean take all the code and run it, the blog has a very clear instructions on how to do that. And then I think all of this entire session would
Sonia, can you just send me those links on the studio chat so that I can send it here?
sure, sure, sure. Yeah, let me do that. Yeah. But yeah, this ends my session. I'll share the links shortly. Just to summarize, right? We looked at some of the architectural design perspective. So I just shared some of some designs on how you can configure your build and release pipelines. But obviously there's a lot more that you can play around with. And for every model that we train, there'll be certain different nuances. Some of you guys might not want to go ahead and outsource things to Azure ML. You would want to do it yourself. So in all those cases, you know that you have a plain Ubuntu machine, so you can basically do install anything on it and run a task using Azure DevOps. Yeah, so this was basically an architectural discussion. So feel to ask me any questions or email me the questions.
Please do ask you all your questions in the chat section. Oh, yep. So, yeah, final call to ask the questions. Meanwhile, I get the links. I'll post those links. Yes, I have the links. Okay, I've shared those links. Please take your learning further from there. And feel free to reach Sonia anytime. And any questions? Mm, or we call for a wrap. Okay, looks like we are good. Thank you all. Thank you, Sonia. Thank you so much for joining us today and for the wonderful session. And thank you, everyone, and enjoy the rest of your day.
Thank you so much, Path, for organizing and putting all of this together. Thank you, everyone who joined.